Take a moment and look around the room you're in right now. Your phone on the table, your laptop, the light switch on the wall. All of it feels normal, ordinary, almost invisible. But what you're actually looking at is one of the most complex and delicate systems humanity has ever built. With a single touch, you can speak to someone on the other side of the planet. In seconds, you can access more information than entire civilizations once held. On the surface, we explain this world with software and the internet, but underneath all of that, there's a much more fundamental reality. This world does not run on gold. Oil alone isn't enough. Even copper isn't at the center of it anymore. At the core of modern life is a single element, number 47 on the periodic table, silver. For thousands of years, humanity treated silver as money. We minted it, we stored it, we protected it. Sometimes we even fought over it. But over the last century, silver quietly changed roles. It stopped being just a store of value. It became embedded inside the systems that power the technological age. From satellites in orbit, to the efficiency of solar panels, to the reliability of digital hardware and communication networks, silver plays a role you rarely see but cannot remove. In many ways, we built our entire civilization on the assumption that this metal would always be cheap and always available. Most people never question that assumption. But what if it's wrong? What if silver is far rarer and far more critical than we have been led to believe? What if its value isn't driven by inflation alone, but by the laws of physics themselves? In this series, we're going to ignore the daily noise of the markets. We're not talking about what happens next week. We're stepping back and looking at the next decade. We'll talk about the limits underground, the rising demands of industry, and the long monetary history that most people have forgotten. This is not a buy or sell pitch. This is the story of a metal that quietly holds the modern world together. To understand why silver matters, you don't need advanced financial models. You only need to remember a chart from high school chemistry, the periodic table. There are 118 known elements. Only one of them sits at the top when it comes to electrical conductivity: silver. Copper is a useful benchmark. That's why it became the standard. But on the same scale, silver conducts electricity about 6% more efficiently. Better than copper, better than gold, better than aluminum. That difference matters, because the world is rapidly electrifying. Every time you press a button, you're re-asking electrons to move from point A to point B as fast and as smoothly as possible. Resistance creates heat. Heat degrades components. Over time, it shortens the life of electronics. Efficiency isn't a preference anymore. It's a requirement. Silver has some of the lowest electrical resistance of any metal. That makes it an exceptionally effective carrier of energy. Decades ago, electronics were large, bulky, and forgiving. Copper worked just fine. Today, everything has changed. We're packing billions of transistors onto chips smaller than a fingernail. At that scale, tiny losses become big problems. Copper generates more heat. Gold performs well, but it's far too expensive for widespread use. So in high-performance systems, the choice quietly shifts towards silver, not because of opinion, but because of physical limits. And silver's role doesn't stop with electricity. Its relationship with light is just as important. Silver is one of the most reflective elements known. When polished, it reflects the vast majority of visible light. That property once made it valuable for mirrors. Today, it makes it critical for energy production. Solar panels work by capturing light and converting it into electricity. Every photon matters. Let too much light escape and efficiency drops. That's why the fine conductive grids on solar panels rely on silver to collect energized electrons and move them out of the system efficiently. Without silver, a panel still looks functional, but it produces significantly less power. This is why silver has become a quiet cornerstone of the renewable energy transition. Governments talk about lowering emissions and reaching net zero targets, and that path runs directly through massive solar investment. And solar investment means silver demand. This demand isn't driven by fashion or consumer preference. It's driven by physical properties. As long as the sun shines, and as long as we need electricity, silver remains necessary. That brings us to a key economic concept: inelastic demand. In most markets, higher prices reduce demand. If meat gets expensive, people switch proteins. If fuel prices rise, usage drops. But some materials don't follow that rule. Silver is one of them. Because in most applications, silver is used in very small amounts, but in absolutely critical places. And that changes how demand behaves. Let's make this more concrete. Think about a high-precision defense system or an advanced aerospace component. The total cost of that system can easily reach into the millions of dollars. Now compare that to the value of the silver inside it. In most cases, it's almost invisible next to the full budget. Maybe the silver used is worth a few $100s. Even if the price of silver doubles or triples, the overall cost of the system barely changes. It's a rounding error, but remove that silver, and the system doesn't work at all. It's like cooking a complex meal. The main ingredients are expensive. But a tiny, overlooked component can ruin the entire dish if it's missing. So the producer doesn't focus on the price of that one ingredient. They focus on what it does, whatever it costs, they buy it. Because the alternative is a product that simply fails. The same logic applies across much of the technology we rely on every day: medical imaging equipment, data centers, electric vehicles, communication infrastructure. In all of these systems, silver represents a small fraction of total cost, but a large share of performance. That's why buyers in these industries don't optimize for cheap. They optimize for functional. Performance matters more than price. And this has an important consequence. Silver doesn't have a natural demand ceiling. When prices rise, demand doesn't automatically collapse. Because demand isn't driven by luxury consumption. It's driven by technical necessity. This also helps explain why silver prices can sometimes move quickly and aggressively. When demand doesn't back off easily, price adjustments tend to be sharper. Of course, this is where skepticism shows up. People say, technology always finds a way. Or, if something gets expensive, it'll eventually be replaced. History gives us examples. Whale oil was replaced. Copper wiring gave way to fiber optics. But silver is different. For decades, scientists and engineers have searched for a cheaper material that can match silver's performance. So far, every alternative has come with a trade-off. Because the periodic table isn't a design catalog. It's a set of physical limits. Elements are the building blocks of the universe, and each one has constraints you can't engineer your way around. Copper has been tested. It's affordable, but it oxidizes, creates resistance, and loses efficiency over time. Aluminum is lightweight, but it conducts poorly and generates heat, which creates risks in high-performance systems. Gold performs well and doesn't corrode, but its cost makes it impractical at scale. So engineering keeps circling back to the same conclusion. Silver sits in the narrow, sweet spot between performance and cost. It's not as limited as copper and not as expensive as gold. The balance gives it a role no other industrial metal can fully replace. Trusting silver in this sense is really about trusting that the laws of physics aren't going to change. And that's a much stronger assumption than betting on short-term trends. Now let's look ahead. We're entering the era of artificial intelligence, 5G networks, and autonomous systems. These technologies are extremely energy intensive. Large data centers consume multiples of the power used by traditional infrastructure. Modern communication networks require thousands of small transmitters embedded throughout cities. All of these systems share one core requirement: reliable, efficient transmission. From server racks to antenna components, from sensors to control units, silver appears again and again. It doesn't draw attention, it isn't advertised, but it quietly enables everything to work. It's almost like the conductive tissue of a global digital nervous system. A metal first used in the early industrial age becomes a silent carrier of the fourth industrial revolution. This tells us something important. Silver demand isn't primarily cyclical, it's structural. When the economy expands, we build more technology. When growth slows, governments stimulate through infrastructure and energy investment. Either way, silver gets consumed. That makes it one of the few materials with what you might call all-weather industrial demand. So, at this point, the demand side of the equation is clear. Silver isn't needed because of fashion, taste, or temporary trends. It's needed because physics and engineering require it. Which brings us to the other half of the story. If demand is this strong and this persistent, can supply really keep up? That's when we have to go underground. Because the most complicated part of this story doesn't happen in markets or boardrooms. It happens beneath the surface of the earth. Now it's time to look at the geology of scarcity. Because to understand why silver supply is so fragile, you first have to understand how the earth actually works. 3 core problems come into play here: dependence on byproduct mining, declining ore grades, and rising energy costs. The world may want more silver, but the planet isn't responding at the same speed. One of the most important truths about the silver market is this: most silver isn't mined for silver. Nearly 3/4 of global silver production comes as a byproduct of mining for other metals: lead, zinc, copper, or gold. Silver isn't the main objective, it's the extra. Picture a large lead-zinc operation in Latin America. Massive amounts of rock are extracted, crushed, and processed so the primary metals can be sold. Along the way, small amounts of silver are separated out. Valuable, yes, but secondary. Often that silver revenue helps cover fuel costs or operational expenses. Now here's the critical question. If the price of silver rises, does that mine suddenly produce more silver? No. Because the profitability of that operation depends on lead or zinc prices, not silver. If prices for the primary metal fall, the mine slows down or shuts entirely. And when that happens, silver production disappears with it, even if silver itself is trading at much higher prices. This pushes silver supply outside the normal rules of market behavior. In most markets, higher prices encourage more production. In silver, price signals often fail to do that. Because most producers aren't actually producing silver, they're chasing other metals. That creates a structural vulnerability. When the global economy slows, construction and industrial activity decline, demand for copper and zinc falls, those mines cut output. And at the exact same moment, green energy investment may be accelerating, tightening silver supply just as demand rises. In other words, we've tied the future economy to the mining activity of the old one. And if that connection weakens or breaks, the consequences can be sharp. What about companies that focus primarily on silver, the ones whose core business is silver mining? They're not as strong as many people assume. 30 years ago, primary silver mines played a much larger role in global supply. Today, their share has fallen below 30%, and it continues to shrink. The reason is straightforward, but uncomfortable. Rich, high-grade silver deposits are becoming harder to find. Silver rarely appears alone. It's usually mixed with other metals. Pure, high-grade veins are extremely rare. As a result, many companies that once branded themselves as silver miners have been forced to acquire gold assets just to survive. Over time, silver companies have quietly become gold companies with a silver credit. And that means something important. There is no swing producer. In oil markets, certain countries can increase output when prices rise. In silver, no one can simply turn on the tap. There isn't a reliable tap left to open. At this point, we run into a fundamental reality of mining: time. Humanity has been extracting silver for thousands of years. We started with what was closest to the surface, then what was slightly deeper, then deposits kilometers underground. The easy material is gone. What remains is lower quality, harder to access, and more expensive to extract. The quality of a mine is measured by how much metal you get from each ton of rock. Decades ago, it was common to extract double-digit ounces of silver from a single ton. Today, many operations are working with single-digit yields. That has consequences. To produce the same amount of silver, miners now have to move, transport, and process far more rock. That means more trucks, more fuel, more water, more chemicals. Costs rise, margins shrink, and physical reality begins to dominate the economic equation. What's happening underground doesn't disappear just because prices move. This is why production costs remain under constant upward pressure. Mining has become a physical contest with the earth itself. And over time, the advantage shifts away from us. Operations go deeper, temperatures rise, ventilation requirements increase, energy consumption climbs. The truth is simple. Every ounce of silver pulled out today requires more effort than the ounce before it. This isn't a cycle that reverses. Ore grades don't improve over time. They decline. We're running faster just to stay in the same place. So a natural question follows. If old mines are running out, can't we just find new ones? That's exactly what exploration companies have tried to do. Over the last several years, billions of dollars have been spent drilling across the globe. Thousands of holes have been sunk into the ground. And what they've found are mostly small, scattered, low-grade deposits. The massive, high-quality discoveries of the past simply aren't showing up. What we're seeing now is what the mining industry calls a discovery gap. The large, high-quality deposits have already been found and developed. What ES being discovered today simply isn't T big enough to replace what DOS running out. And even if a major silver deposit were discovered tomorrow, it wouldn't solve the problem in the short term. Bringing a mine online takes time, a lot of time. Feasibility studies, environmental approvals, infrastructure, processing facilities. It's not unusual for the entire process to take a decade or more, which means this: the supply for the next several years is largely already set. We have a pretty good idea which mines will be producing 5 years from now, because they are either already being built or they don't exist at all. New capacity isn't coming online fast enough to replace the old mines that are closing. As demand accelerates, supply is facing a steep uphill climb. There's another way to think about mining as well. At its core, mining is an energy business. You burn enormous amounts of energy to pull value out of the ground. When energy was cheap, that equation was easier to manage. But the world is moving into an era of more expensive energy. Easy resources are gone. Environmental regulations are raising the cost of fossil fuels. And under those conditions, mining becomes more expensive by default. Below a certain price level, production simply isn't sustainable. If the energy required to extract an ounce of silver approaches the price you can sell it for, operations shut down. Every closure tightens supply. And tighter supply increases pressure on price. That's why energy costs and silver prices are directly linked. This isn't a psychological relationship. It's a physical one. Seen this way, silver isn't just a metal. It's concentrated energy. Inside every small bar of silver is the energy history of breaking rock, hauling material, and processing ore. As energy becomes more expensive, that embedded cost has to be reevaluated. This is one of the reasons silver is often viewed as an inflation-resistant asset. Not because people feel safer holding it, but because the cost of producing it rises with inflation itself. Now let's look at the map. Where does silver actually come from? The answer is simple and uncomfortable, mostly from outside the United States, Major production is concentrated in parts of Latin America and Eurasia. These regions supply a large share of global silver, but their political and social dynamics are changing quickly. More governments are asserting control over natural resources. Taxes are rising. Certain mining methods are being restricted. Contracts are being renegotiated. Labor strikes periodically shut down production. In some regions, security risks make transportation more difficult. All of this adds an uncertainty premium to supply. At the same time, some countries, facing geopolitical tensions or prioritizing domestic needs, are choosing to keep what they produce rather than export it. That reduces the amount of silver available on the open market. The result is a supply chain that's becoming increasingly fragile. From a strategic perspective, this matters. In the event of a major geopolitical conflict or trade disruption, silver flows could be interrupted overnight. And there's no meaningful buffer to absorb that shock. Large strategic stockpiles are limited. The system operates largely hand-to-mouth. When you put all of this together, a three-way pressure emerges. Geology is getting harder, supply isn't flexible, and geopolitical risks are rising. But there's still one question people ask. If underground supply is so constrained, can't we solve this above ground? Can recycling fill the gap? That brings us to the third variable, the one that truly separates silver from most other assets: consumption. Some assets are stored, some are burned. Silver lives in both worlds, and that dual nature opens the door to the real disappearance. So let's pause and look back over the last century, almost like a forensic investigation. Humanity has mined enormous amounts of silver during this time. The numbers are staggering, tens of billions of ounces. So where is it now? Not in vaults, not in jewelry boxes. A large portion of it was quietly thrown away. At this point, economics meets physics. There's something called the thermodynamics of waste. Much of the silver we use today is technically recyclable on paper, but at current prices, it's not physically or economically rational to recover. That's why above-ground inventories are far smaller than they appear. The world assumes there's a buffer. In reality, we're moving forward without a safety net. To understand this better, we need to compare silver to its closest relative, gold. Gold is almost the perfect recyclable asset. Most of the gold ever mined is still in circulation today. Because gold is valuable, it doesn't get discarded. Rings, coins, and jewelry are melted down and reshaped across generations. Gold stays above ground. It accumulates. It doesn't disappear. Silver doesn't share that same story. Over the course of human history, we've mined far more silver than gold. And yet today, the amount of clearly identifiable, accessible silver above ground is dramatically smaller. The reason is simple. For a long time, we treated silver as a consumable material. And that decision came with a cost. This loss didn't happen overnight. It happened slowly. For much of the 20th century, one of the largest uses of silver was photography. Film, X-rays, and printing processes all relied on silver. Millions of ounces were consumed every year. Some of it was recovered, especially in large laboratories. But at the consumer level, in old photos, family albums, home archives, most of that silver quietly exited the system. It became locked inside paper and eventually ended up in landfills. In other words, humanity spent a significant portion of a strategic resource in exchange for memories. Photography faded away, but it was replaced by something even more pervasive and far quieter: electronics. In the past, silver was used in visible, substantial forms. Cutlery, decorative objects, coins. These were items you didn't throw away. Today, silver is used in microscopic quantities, almost like dust. It's inside circuit boards, sensors, tiny switches. It's everywhere, yet almost impossible to see. Each device contains very little silver, but when billions of devices are produced, that invisible amount becomes massive consumption. And when a household appliance breaks, no one takes it to a precious metals refiner. It goes to the trash. This is how silver ends up scattered across the surface of the planet. From a physics perspective, this is rising entropy, a shift from a concentrated, ordered form into a dispersed state that's extremely difficult to recover. Think about the energy required to produce a single bar of silver. Now imagine that bar broken into millions of fragments and spread across landfills. Reversing that process usually isn't worth the energy it would require. Yes, in theory, you could dig up a landfill, process tons of waste, and recover a few grams of silver, but the energy cost would exceed the value of the metal itself. That's why, in industrial use, silver often follows a one-way path: mine, factory, landfill. This is what separates silver from other precious metals. It behaves like money, but it's consumed like fuel. Some of it is stored. Most of it is burned inside systems. That dual nature is what creates what we can call the great disappearance. At this point, a common objection comes up. What about solar panels? They're large. We'll recycle those. On paper, that's true. Solar panels contain meaningful amounts of silver, but time changes the equation. These panels are designed to operate for decades. The The silver installed today is effectively removed from the market for a very long time. So even if it's recyclable in theory, it doesn't solve today's problem. Right now, we're in the accumulation phase, not the decommissioning phase. Billions of ounces of silver are being bolted onto rooftops and fields. There's no exit yet, only entry. This makes the picture clearer. From a silver perspective, the solar industry is a net consumer. Silver leaves vaults, gets embedded into panels, and stays there for years. For the foreseeable future, this sector acts like a sink, pulling silver out of circulation and locking it away. And engineers have already pushed efficiency as far as they can. Efforts to reduce silver content have hit physical limits. In some next-generation panel designs, silver usage is actually increasing again. The pull isn't weakening, it's getting stronger. So where did all that silver go? Naturally, people assume governments must still have reserves, strategic stockpiles held back for emergencies. And in the past, some did. At one point, the United States held one of the largest silver stockpiles in the world. It had been built up over decades and served as a meaningful buffer. But over time, silver's monetary role was abandoned. It was removed from coinage, it was labeled unnecessary, and it was sold. For years, public silver was steadily released into the market. Eventually, that stockpile was effectively exhausted. Today, the situation has reversed. The government is no longer a seller. It's a buyer. Silver must be purchased for official uses. The actor that once supplied the market now depends on it, which leads to a simple conclusion. If a real supply disruption occurs, there's no massive reserve waiting to be opened. In other parts of the world, the approach is very different. Some countries have been quietly importing silver for years, but not exporting it, and they don't publicly disclose how much they hold. These reserves aren't meant for trade. They're held for industrial use and strategic purposes. That alone tightens the amount of silver freely available on the global market. From the perspective of the individual investor, this matters. The silver that's actually accessible is far more limited than it appears. The inventories reported in places like London and New York represent, in many ways, the last visible layer of supply. And the amount of metal sitting in those warehouses, the metal backing paper markets, has been steadily shrinking. This decline isn't driven by panic, it's driven by a disconnect between paper prices and physical reality. When the price set on paper doesn't reflect real-world scarcity, some large players respond by buying contracts and demanding physical delivery. That metal then leaves the system and moves into private vaults, often permanently. This doesn't happen all at once, it happens quietly, month after month. As inventories shrink, the system becomes less flexible. On the surface, markets still function. But underneath, the physical foundation is thinning. If this trend continues, the link between paper markets and physical supply comes under real strain. In that scenario, it's hard to expect prices to remain where they are, because physical scarcity, sooner or later, forces repricing. This is also where the green transition narrative deserves a closer look. We often hear about a fully circular economy, one where everything is recycled. It sounds ideal. But recycling has costs. It requires energy, labor, chemical processes. And at today's prices, many of those processes simply don't make economic sense. Take solar panels as an example. Yes, the silver inside them can be recovered. But in many cases, the cost of recovering it exceeds the value of the metal itself. Faced with that equation, recycling doesn't happen, disposal does. And that means silver exits the system permanently. For recycling to scale, silver prices would need to rise to levels where the process can fund itself. Until then, price pressure is décroissant. It's like a T, just driven by investor behavior. It is driven by physical and economic necessity. When you step back and connect all the dots, a clear picture forms. The laws of physics haven't changed. Underground conditions are getting tougher. Consumption moves in one direction, and the system hasn't fully priced these realities yet. If silver were just another industrial metal, this imbalance would likely have corrected itself already. But silver has another identity, one that has been pushed into the background for a long time. Money. This is where the story shifts, from factories to banks, from physics to economics. Because you can understand today Essett's silver price without understanding why silver was money for thousands of years, and why it stopped being money. Political decisions can permanently alter the nature of money. That's exactly what happened in the past. At a certain point, silver's free circulation was restricted, and the system moved toward a single metal standard. That decision weakened silver's monetary role and broke a historical link. Silver was gradually pushed out of its role as money and redefined as just a metal, valued for utensils, photographs, and circuits, but not for what it had represented for centuries. Yet one truth didn't change. The fundamental properties of money are constant. It must be durable, divisible, portable, and above all, scarce. Modern fiat systems struggle with that last requirement. As debts grow and money creation accelerates, scarcity erodes. And over time, trust follows. History shows that during periods like this, people tend to move toward assets whose value isn't dictated by policy decisions, but by physical reality. Today's global debt levels have brought that discussion back into focus. In some countries, the scale of debt pushes the limits of repayment math. When you reach that point, the options narrow. Either debts are restructured openly, or their burden is reduced through declining purchasing power. History suggests governments choose the second path more often. In those environments, people look for ways to preserve wealth: real estate, art, precious metals. But each option has limits. Real estate isn't liquid. Art is subjective. Gold carries a high entry cost. That's where a more accessible alternative comes into view. Silver fills that gap. It behaves like money, but it's reachable for a much broader population. And because of that, demand doesn't form from the top down, it forms from the bottom up. While central banks accumulate gold, individuals turn to silver. And there are far more individuals than institutions. There's a comparison that comes up again and again when people talk about silver. It's called the gold to silver ratio. In simple terms, it asks one question: how many ounces of silver does it take to buy 1 ounce of gold? Geology suggests one number, mining data suggests another. Long-term historical averages point somewhere else entirely. Today's market ratio sits far away from all of them. That gap isn't a prediction by itself. It's more of a signal, a sign of imbalance. If the monetary system ever goes through a real rebalancing, this ratio has the potential to move back toward historical ranges. That's not guaranteed. Nothing is. But history shows that during similar periods, this kind of adjustment has happened before. In moments like these, psychology matters more than price charts. When people sense that their money is losing value, decisions speed up. Instead of reaching for options that feel expensive or out of reach, they gravitate toward what feels accessible. And when that behavior hits a small, shallow market, the impact can be dramatic. Silver fits that structure perfectly. Compared to other major assets, the silver market is relatively small. That means sudden, widespread interest doesn't just nudge prices, it can move them aggressively. We've seen this dynamic play out before under very different conditions, but the pattern is consistent. When physical supply is limited and demand accelerates, prices respond quickly. If we step back and pull everything together, what emerges is a layered picture. On the physics side, silver has properties that are difficult to replace. On the industrial side, demand is growing and substitution is limited. Underground, extraction is getting harder. On the consumption side, much of the metal doesn't come back. And monetarily, silver carries a role that was suppressed, but never fully erased. When all of these forces line up at the same time, you get a rare intersection. In the past, some of these elements were present, others weren't. Today, both monetary pressure and physical constraints are being felt simultaneously. That's what makes this moment different. This is why focusing only on today's price can be misleading. Numbers don't always tell the full story. Markets don't price everything at once. Sometimes recognition lags reality. In the end, everyone makes their own choices. Some people observe, some wait, some prepare. But one thing is clear: silver isn't just a relic of the past. It has the potential to be part of the future as well. And perhaps the most interesting part of this entire story is this: an asset that has been ignored for a very long time may be entering a phase of rediscovery. No one can say exactly when. No one can say how far it goes. But the real question has shifted. When the world starts taking that possibility seriously, will prices still be where they are today?